Hi, this is a Tempter podcast where we explore the latest open source Linux and IoT technologies and workflows that enable innovative teams to build products better. Your hosts today are Cam Raj and Cliff Brake. So today we have a special guest, Drew Moseley from Toradex, and Drew is a technical solutions architect at Toradex, so we're glad to have him with us and look forward to learning.
Yep, great. Thanks for inviting me.
Yeah. So Drew, maybe to start off, you could just give us a little background on your career and how you got to where you're at today.
Yeah, sure. So, I if I could grow facial hair, you could call me a graybeard. So I graduated college in '94, started working in '95 for actually the Motorola Paging Products Group. Back when pagers actually existed, and that was really my first exposure, you could say, to embedded software. I had done hardware digital design courses, things in college, and they had a one semester course on 68HC11, I think it was, but there wasn't much in the way of embedded stuff. So that was kind of like trial by fire. It was still an RTOS. It was a RTOS called OS9 from a company called Microware out of Des Moines, Iowa. And it was all assembly based. The OS was, but everything we put on top of it was C code. From there, I went to a company called Cygnus Solutions that was, I think, maybe one of the first commercial open source companies out there. They did GNU toolchains. They had a toolchain called GNU Pro. It was mostly bare metal code toolchains for a wide variety of architectures, and it was all services related business. From there, I was at Intel for a while doing supporting some of those tool chains as well as supporting some of the RAID processors and things like that, and moved on from there. After I left there, that's when I really got into embedded Linux primarily. I was at Monte Vista for a long time, and then Mendor Graphics, which is where I had my first exposure to Yocto. And then after Mendor, I was at Mendor working on over-the-air updates for embedded Linux systems. And now I'm at Torizon doing pretty much the same thing, a little bit bigger picture, full stack stuff than I was doing at Mendor, but it really kind of brought together all aspects of things I had done in the past.
That's a long, illustrious career there. I think you started off with really, really embedded devices.
Yep.
And,
yeah, it's been a while since I've been that deeply embedded. So, when I start to look at some of these MCU topics and things, it brings back memories, but, I'm definitely rusty on some of that stuff.
Sure.
Yeah, that's neat to hear about Cygnus and all those companies, that we've heard of throughout our career with Linux. Yeah.
Yep.
So very interesting.
Yeah, I can't complain. It's been I've enjoyed my career. I like the fact that I'm still technical. I'm not a core member of the dev team here at Toradex, so I'm not sitting in front of a code editor all day, every day. I am customer facing. I'm out giving talks, doing technical marketing, things like that. I'm also kind of the first line of interference between our customers and the dev team to help drive feature requests and make sure customers are using our products in the way that they have been designed.
Mm-hmm.
So tell us more about Toradex. What does Toradex do, and what do you do at Toradex specifically?
Sure. So Toradex has been around a little over 20 years now, and Toradex makes system-on-module boards today for running embedded Linux. When we started, it was mostly Windows CE. So back in the mid 2000s, we had a lot of chips based on the T20 and a bunch of other chips, which I've never even dealt with, that were all Windows CE based. And I guess probably 5 to 7 years into Toradex's history, they started moving over to the embedded Linux space and have traditionally provided a Yocto BSP, fairly well supported, fairly full featured from the perspective of drivers and hardware needed for the modules. But beyond that, it was really up to our customers to fill out the rest of the stack. So they would use just traditional Yocto workflows, starting from our BSP, add their custom layers, and they would get to make all the decisions on their board. As Windows CE, I guess it's been discontinued or will be shortly, and regardless, a lot of the chipsets that they run on, you can't get anymore. as that was going down, we realized that we needed kind of a migration path for those WinCE customers, most of whom don't know much about embedded Linux, Yocto, or anything like that. So I guess about 5 years ago now, we started developing Torizon, which we describe as an opinionated stack. It is a Yocto-based distribution. Yocto, of course, famous for providing mechanism, not policy. You can change just about anything you want. With Torizon, our idea was, okay, let's make a few decisions on behalf of our users so that they don't necessarily need to do that. So we use systemd. We've got the specific kernels and bootloaders and things like that. We also started adding in the things that are very widely used in today's devices, things like over-the-air updates, remote access. So those kind of things are all baked into the system with the goal, at least initially, of providing a migration path, like I say, for these WinCE folks. And that system's called Torizon. Mm-hmm. And it's on the client OS side, it's a standard Yocto distro. We provide a layer. We've got our custom images, our custom machines, our custom distros, all that, which lays all this out. If you want to work with it at the Yocto layer, you can do that. That's fully supported. It's fully open source. No licensing for the client side code. In addition to all the things for the cloud connectivity, we have a container runtime. We have a Docker runtime. We also have experimentally Podman and a few others that our team has played with. And the idea is for those that don't want to know Yocto, don't want to know Linux, they can build their application stack inside the container and not have to deal with the complexity of a full Yocto build. We provide tools to allow them to customize the base operating system without going back to the full Yocto build. While they can, if they need to, for the common kinds of modifications and customizations you want to make to that base operating system, we provide a tool called Torizon Core Builder, which can take a pre-built binary image, pull it apart. It can add things like additional kernel device drivers for things that might be on your carrier board. It can change, media and branding assets, splash screens, things like that, add config files, and then package it back up into an image format that can be installed directly on the board or deployed to a fleet of boards over the air. So that's the tooling we have for customizing the base operating system. Now, when it comes time to develop the applications, we also have a Visual Studio Code integration that allows you to develop your containerized application directly from VS Code. And, kind of the ideal model is a developer that knows nothing about containers, knows nothing about Yocto, but, they might be a C# programmer and they know their domain. They sit down, they say, create a new Torizon project. They select the language and or framework they want to develop in. It drops them in a code editor and they start typing code. And then our extension is also set up for cross debug across a local area network. So it just uses SSH on the board with a local area connection. And you can do all your source level debug directly in that IDE extension. And it also has it also plugs into our cloud solution. So when you're ready to move from a development image to a production image and actually push it out to the cloud infrastructure, you can do that all from within that IDE extension, so that when it's time to actually deploy a new version to your entire device fleet, it's there. And so all of that I've talked about, the tools and the client OS is open source, and there's no charge. There's no licensing fees or anything. The only time there's a charge for this system is when you plug into our software as a service infrastructure and are using things like our over-the-air updates. Obviously, we have recurring costs for that, so that's not something that we can bake into the price of the modules or anything like that. And so that's kind of the brief overview. But the objective of the Torizon system is to support these kind of connected Internet of Things devices throughout the entire lifecycle. So you got all the tools for development, customizing the system, getting that up and running, all the tools for maintaining the fleet over the life of the project. So all the over-the-air updates, which I've heard you guys talk about quite a bit. So it's those kind of things are very common. We also have remote access, device monitoring. So we have basically time series metrics that can come back to our server and kind of give you a snapshot of the state of your devices at any given time.
Mm-hmm. So that's quite a bit, and I think we've looked. I think Cliff has looked more than me on Torizon, and and he has some experience there. But I guess you have chosen an OTA technology, so it seems that you are building an end-to-end solution, considering from developer to deployment and
exactly.
So we'll talk about the OTA talk and other OTA things that you did. You presented recently at the EOSS summit.
Correct. Yep.
And so I think before we go there, what are some of your common customer problems?
Yeah, so that's a great question, and obviously this changes on a month-to-month basis. I think probably the biggest thing people have is what the heck is Torizon? What the heck is a Linux? What is a container? Right. So there's a lot of new technologies that people need to come up to speed on. We do have plenty of users that are old hands at Yocto, and they're like, I don't want containers, just give me a way to get rid of the containers and I'm going to go to Yocto. And we have, like I say, people that have never even looked at a shell pump. So the wide range of experience levels for our customers can be pretty tricky. I think we have excellent documentation, excellent support that helps you no matter what level of experience you have on these systems and everything that's involved with them. Mm-hmm. One interesting thing, and I don't know if you guys have noticed this, but now that I'm at my second company doing over-the-air updates, one of the strange things that I see is the amount of pushback I get from users to why would they need an update system in the first place? Or they just wait to the very end and say, hey, we want to go to production in 2 weeks. Can you help me add OTA updates to the system? And to me, I'm just like, how can you imagine that that's going to be it's not just a checkbox on a PowerPoint. So that's one of the things I'm curious about is why the resistance. I mean, I understand the cost from the cost perspective, the pushback, but just the idea that, well, why would I even need to do that? That's kind of a strange thing that comes up a lot.
Yeah, it's completely backwards because that's the first thing I do because it's an invaluable development tool.
Absolutely.
If I can decrease my cycle time and push software updates to my development units quickly, that speeds up my development velocity.
Absolutely.
So I think it's completely backwards to think about it that way, Yeah,
and it's also a fairly invasive change to the system. I mean, coming in at the last minute after you've done all your testing, and now, if you're using a multi-partition setup, you're changing partitions, you're changing things at the very low levels of the system that could have wide-ranging ramifications, and that's one of that's definitely something I struggle with when talking with people, is trying to explain why it's needed and what the issues are with it and why you should care early rather than just assuming it's simple and they'll just add a shell script running apt update at the end of their development process.
That's so important. I'm glad you're on that, because that's definitely something that we need to educate the industry about. So
yeah, absolutely.
Yeah, I think
that's a big part of my role here, right? That's why I'm giving the talks at the various conferences and things, is trying to get the word out and have people start to investigate these options earlier on in the design cycle.
Sure.
Mm-hmm. So I think, how do you go about solving some of these issues? I think you touched on documentation, but are there other things that you kind of go about helping your customers solve their problems?
Yeah, I mean, specifically at Toradex, we have a very hands-on relationship, especially, Torizon is only 5 years old at this point. It's fairly early. So we've got a very hands-on relationship with many of our customers. And for some of them, the definition between support and professional services is kind of blurry for us. So if somebody needs us to implement a proof of concept, give them some getting started scripts and things that show them how to do certain things, we can have the flexibility to do that. A lot of what I do is find, somebody had a confusion over something in our documentation. So then I dig into it with them, understand what was missing, where it was missing. If it was just a simple change, I can go and make it. We've got a PR-based system where I can modify the docs. If it's something more significant, then of course I'll bring in the official tech marketing folks. So just keeping our documentation updated based on issues that our users are having, I think is an important thing. And then, getting out, giving talks, trying to, kind of go in between the very deep technical documentation and the getting started guide, right? There's a big gap between those. And, how do I do this kind of application? How do I develop a connected dashboard for, weather sensors or whatever it is? And, not necessarily going to, all the levels of detail, but just say, hey, these are the kind of architectural things you want to think about, how you might start to structure a system and how you might start to get a sense for, what are the big user stories and things like that you'll need to think about. So that's one of the things that I'm trying to do at Toradex is help get that middle ground. We've got great, very deep technical documentation. Our getting started stuff is really good, and then just trying to kind of build out that kind of set of use case style documentation, which might be a little less formal, might be in the form of a tutorial, might be in the form of a blog, something like that. So those are some of the efforts that we have for kind of getting our users onboarded as painlessly as possible.
Yeah. So I think Cliff and I, we were talking about Torizon the other day, and I think Cliff observed this, that the upstream first policy, and it kind of ring bell with us because we maintain Yo distro, and we are basically maintaining a master based distribution essentially. And anything we do, we basically round trip it through the respective upstream, and then it comes in the next monthly cycle back into our distro. So could you talk about what is Torizon's upstream first policy and
So that actually is more for our BSP team. We most of our modules are NXP based. We now have a few modules that are TI based. So traditionally, we've had a very kind of a split brain view of the world. We had the upstream and we had the downstream. And so the newer NXP chips, the IMX8s, and the IMX95 that we're developing now, most of that code is not upstream. That's just in the downstream NXP. So, there's only so much we can do there, but certainly for the older chips, the IMX6 and IMX7 based, the stated model for starting with our current BSP release, which is BSP version 6, all of our IMX6 and 7 work happens upstream first. So, the kernel team, they submit to, kernel.org or whatever, and then finally bring it back down. And I know they're doing that with a lot of the stuff that's in the IMX8 and IMX9, but that has to be decided on a case-by-case basis when it makes sense to do that. On the Torizon side of things, there's not really an upstream for a lot of what we do. A lot of the code for Torizon, of course, is the Yocto layers and the metadata, and those are open source, but there's not really an upstream for that. But for all the packages that we add, the update client, which is Actualizer, is we have a very good working relationship with that community, and we've submitted plenty of fixes up there. So while I don't know that we have a formally stated process of upstream first on those kind of things, that's certainly within our vested interest to do that as much as possible.
Yeah. I think our experience so far with some manufacturers has been there, that you freeze the software in time, and then you kind of like try to get it working after a while, and the things have rotten out. They're using very old versions of tools, very old versions of everything. So from that aspect, I think what Cliff observed, and I think we were looking at, is that this is something different in that space. Which is
sure, and we struggle with that too, especially on the our downstream versus upstream. I don't remember the exact kernel version numbers, but I'm pretty sure our Torizon 6 on, say, a Palace IMX6 is quite a bit newer of a kernel version. It's a 6 dot something, and I think on the Palace IMX8 it's a 5.15, I believe, because that's what NXP currently supports. And so until enough of the functionality makes its way upstream, we're still kind of reliant on NXP for some of this, especially for, the things that maybe not documented as well as we would like, all the graphics and neural processing units and all that kind of stuff. The trying to keep newer versions is a struggle. In general, we follow the Yocto LTS strategy. So our BSP5, Torizon 5, that was based on Dunfell. now we're BSP6 is Kirkston, and BSP7 team is starting to work with Scarthgap as we speak. So we tend to follow that LTS. The fact that the Yocto project came out with the LTS release was a big help for not just us. I'm sure a lot of other customers, a lot of other users have similar kinds of models now.
Yeah, that's another area where like now Dunfell is going to be EOL. So what's your strategy of supporting it longer in your community? I guess you probably have longer support cycles.
Yeah, we definitely will. And I don't know that we have a formal policy stated on that, but we'll just continue to support them through our standard support channels. We've got a lot of folks with Yocto expertise, so we'll do the best we can to keep that BSP5 version of our products alive for as long as our customers need it. That said, especially with Torizon, we try to make it very easy for users to migrate from the 5 to the 6. We actually support over-the-air bootloader updates in the 5 to 6 major version jump, just to allow them to move to that newer version of the bootloader that is in our Kirkstone branches. And moving forward to BSP7, we'll maintain that as well.
Yeah, that's super important to make sure we can update the entire system, because when you're looking at 10-year life cycles, and Kim just shared with us last week that the kernel LTSs are going to be 2 years now or something like that. So,
right. Yep.
We have big system updates coming. So yeah, it's great to see some vendors moving. I was just talking to another engineer, and he said that every time his hardware provider gives them an update, it's a 50 gigabyte download of a Yocto build tree or something. And I can't describe how many times I've run into that.
Yes.
So
agreed.
Yeah, it's just really refreshing to see companies putting stuff in Git repos.
Absolutely.
Trying to track upstream, whether that's, Freescale upstream or kernel main, something upstream to keep moving forward.
Yep. Yeah, that's like I said, that's a big goal for us, because it reduces our effort over the long run. And I talked to somebody a couple of weeks ago. They were looking for 20-year support. And, I kind of pushed back on that one and suggested they at least reduce, get rid of the requirement that they have to stay on the same major version. If they're going to be around that long, they're going to have to move major versions. That's just not even feasible to do it any other way.
Right. Yeah, I just saw this week that Chrome pushed out some updates for pretty critical security issues. And, in the browser world, there's no such thing as LTS.
No, that's true.
It's you track the latest, or else you're behind, and you've got potential security issues. And as browsers.
Well, that's been the talking point of the kernel community over the last 12 to 18 months. I've heard a lot of people say that if you're not on the latest dot version of whatever officially supported major version, your chances are pretty good you're vulnerable to something.
Yeah. So I think you talked about Torizon being a relatively young distribution, like 5 years or so, but I'm sure that you have some thing to share about the challenges. I think you've been mentioning a bit here and there today. But what are the challenges that you're seeing for maintaining and embedded Linux distribution?
Yeah, so I think probably one of the biggest is just the variety of industries and use cases, which each have their own requirements, right? If you look at regulatory requirements and things like that, and some of our medical customers have very tight regulatory restrictions. They can't do over-the-air updates because their devices are not allowed to talk to the network and things like that. So, related to that is also just the long cycle times that these customers have. We have so many people come to us. Yeah, we're going to go live for production in 6 months, and 6 months later they say, yeah, it's going to be 6 months, and it ends up being 2 to 3 years, and that seems to be kind of about the right cadence, right? Anytime somebody comes and says we're just starting a project, it's going to be 2 to 3 years before they go live with it. So. those long cycle times do make for a challenge in developing any product, because when they're in development, even if they are planning on using our paid services, they're not going to have a large number of devices for the first couple of years. So that definitely is a challenge, certainly from the business side of things. Just on the technical side of things, it's the sheer fire hose of sources we have for vulnerabilities, bugs, all the sources that go into this system. How do we have a way to monitor all these things and make sure that if there is a critical vulnerability in glibc, that we get it. Fortunately, we're based on Yocto, and Yocto has a pretty good CVE policy, so we're able to piggyback on a lot of the good work that Yocto and other projects that we're based on do. And I think that kind of goes back to what we were talking about earlier about upstream first, playing nice with upstream projects and things like that. It just makes your life so much better over the long run because you're able to use the work that other people are doing.
Yeah.
Mm-hmm.
And so I think now speaking of distributions, and I think looking at, we talked about OTA being one of the key components,
Mm-hmm.
and Torizon has its own OTA selection, and you said that it's an opinionated distribution.
Correct. Mm-hmm.
And I like that because I think with the work Cliff and I we do with Yo, we are in the same boat.
Sure. Sure.
So so could you talk about your OTA solution and pluses and minuses of
Sure. So just mechanically on the device itself, there's two main components that get updated. One is the base operating system, and the other is the container runtime. We use Docker containers, and so we didn't really design anything there. That the Docker images, Docker layering, the ability to fetch images and all that is built into Docker. So that was one of the reasons we chose that. So from the application container side of things, it was all defined by the fact that we were Docker based. And on the OS side, we use a technology called OSTree to essentially store multiple versions of a bootable file system in a single partition. So unlike most OTA solutions that use either an asymmetric approach or a dual partition approach, OSTree allows us to have just a single partition. And then within that partition, there's a repository of objects, very similar to Git's content addressable file store. So every file that goes into a bootable file system goes into that repository. And then hard links are used to create a specific bootable file system version. And there's some code in the bootloader and in a init ramfs that allows the kernel to select the appropriate version at boot time. And so that gives us that flexibility to be able to boot while maintaining the old version for rollback. Some other benefits of it are just the deduplication. If I am installing a new version that only modifies 4 files, I only have to download and store 4 new objects. Since they're hard links, any file that is unchanged from release to release is a hard link to the same object in the repository. So that obviously reduces the amount of data you need to download, but it also reduces the time of the update process. The one downside of it is that it requires a reboot for any OS update. There's no way to do an in-band, say like an APT update where you're just updating individual packages. At development time, there are things you can do to do things like that, but certainly that's not a best practice for that OSTree setup. So that's the mechanics of it on the client side. And like I said, we also have bootloader updates, and we have a technology called subsystem updates, which basically is a plugin architecture that allows you to create a custom payload type. Bootloader updates are actually implemented as a subsystem update, and you create a plugin that knows what to do with your particular payload. So if you're downloading an MCU firmware image that gets copied over USB to an MCU, you just write a script that knows what to do with it, and then you're able to actually download that payload from our cloud service. Mm-hmm. And then on the cloud service side of things, we're based on a standard called Uptane, which is a security standard for automotive over-the-air updates. So it came out of the automotive space. And, for those that are familiar with the automotive space and the software in them, that's a very complicated space. There's, potentially, dozens or maybe even hundreds of ECUs in any given high-end automobile today, each of which might need an update. And so Optane provides, and let's be clear, I'm not the security expert on Optane, so I can't give you all the details, but it's basically a spec that says, okay, here's the bits of data, metadata that define your repository of things that can be installed. And then there's also metadata about all the devices in the repository and things like that. And it's the spec that says, okay, we've got all these different signing keys that can sign certain pieces of metadata to give us certain guarantees about the authenticity and integrity of this repository. So, typically, if you just sign the artifact and you verify the artifact with the public key on the device, that gives you some amount of guarantees. But there's nothing stopping a replay attack in that case, because that artifact is signed by a valid key. And so, Optane goes one step further and basically signs the entire repository contents, so that if I mark an image as bad, as part of Optane's validation of all the signatures, it's going to see, hey, this image that this person's trying to install has been revoked, so I'm not going to even try to revoke it. So it's really intended to protect against, nation state level attacks. I mean, if you look through the spec, they actually state that in the spec, that their goal is to be able to protect against nation state attacks. So, the replay attacks are a big concern. Things like freeze attacks, where even though there's an update, there's a man in the middle that is basically sending the wrong information that there's not an update. Based on the way you're actually signing the entire repository, you're able to detect those kinds of issues and mitigate them.
Mm-hmm. So I think it's very interesting, I guess. And I attended also your talk on, the OTA comparisons, and that was very interesting. So would you like to talk about how it compares? There are other solutions out there.
Sure.
Some of them are homegrown, maybe some of them are open, or some of them are products. So how do you draw that comparison, in terms of, you talked about security, but then there could be like size, delta updates,
right,
and that sort of stuff.
Yeah, and my talk at the recent Embedded Open Source Summit was a comparison of basically the four main update third-party updaters that people are using today. So it was Mendor, RAUC, SWUpdate, and then Torizon with OSTree. And it was solely focused on the size implications of any update methodology. The kind of background for it came from some of our users who have very low bandwidth Cat M1 modems on mobile devices that are, on vehicles traveling all across wherever they're located. So they're going in and out of connectivity. They've got extremely low bandwidth even when they have stable connectivity. So we've done a lot of work to optimize throughout the entire workflow the amount of bytes that people need to download. So all of those updaters that I talked about have a mechanism for doing binary deltas. Without binary delta, basically each system has its own artifact format, and that's just essentially some version of a fancy tarball with metadata that says what to do with it. But then if you want to be able to reduce the size of that, you can do binary deltas between that and older versions. One of the complications there is it's usually very dependent on what version you're going from and what version you're going to. So for instance, both Mendor and OSTree require a read-only root file system, because the binary delta is calculated offline, and the system has to know that your root file system has not changed if that binary delta is going to apply cleanly. RAUC and SWUpdate use different mechanisms that allow that file system to change at the cost of a potentially larger download size. So they're able to actually calculate. I didn't dig too deeply, but they're kind of a block-based comparison, and it says, I've got a block with checksum 6 and a block with checksum 8, And so you don't need to send those. But generally speaking, RAUC and SWUpdate, because of that, their binary delta algorithms did not reduce the size as much as both Mendor and OSTree.
Mm-hmm.
And of course, OSTree has a built-in, I think, advantage because it is file-based to begin with, and you're only transferring new and modified objects. Even without static deltas, OSTree is generally going to require less data to download, especially if you're not making huge changes from one release to the next, right? You're making fairly modest changes. You're only changing some versions of things. You might be able to get away without static deltas in OSTree. But if you do need to go that next level, the OSTree provides a functionality where you're doing basically per file static deltas. And instead of transferring each object in full, you're actually doing a binary diff based on what's on the device and what objects might be there to reduce the size of the individual objects that need to get transferred. So that was really the focus of that talk, was just to say, hey, how do these systems perform? They all perform pretty well. Is certainly, any binary delta algorithm is going to reduce the amount of data that you have to download. Of course, there's the at the expense of more CPU processing and probably a longer install time, just due to the amount of the processing needed to regenerate the updated image.
Yeah. Mm-hmm. So I think one thing I hear about, say, OSTree is at least if you compare to something like apt or the RPM. So there is a database on device, and if that database gets corrupted, then you lose the state of the system. So where does lie the kind of information in terms of OSTree? So a lot of times people think that if I kind of like lose this information on my device, then I'm out of sync. How do I recover, and all that scenarios.
That honestly, that's not something we've had any issues with. File systems these days, the journaling file systems are fairly robust. And of course, you can always run an FS check on your file system to help with that. And in the life of Torizon so far, we've just not seen issues with OSTree corruption. One thing I did mention is, OSTree requires a read-only root file system. And, there's a very big concept now that's getting a lot of press called immutable operating systems. And, the idea is that immutability is one part, but it's really more about the fact that it's an atomic update. So, OSTree is designed to allow these atomic updates. Basically, the very last step of an OSTree update is a single creation of a symlink. And so that either that symlink gets created or it doesn't. And that's what gives us the atomicity of these OSTree updates. Mm-hmm. But as far as, file system corruption that would make OSTree unmanageable, I've not seen that. I know in Torizon we have some services that can help with various types of troubleshooting issues. I know we've got some things on the Docker side where it might try to refetch Docker images and things like that, but I don't know of anything on the OSTree side. It does, when it downloads, it downloads everything to a staging area, and that's part of its architecture for allowing power safe updates. So if the power gets rebooted at the wrong time, all my updates that are in the staging area get flushed, and they'll have to get re-downloaded. But that overall gives us a pretty good and strong and robust system with OSTree.
Yeah, that's fascinating. So how does it work to like purge old data that you don't need anymore?
Well, yeah, OSTree, the actual OSTree technology supports an arbitrary numbers of versions, but we only ever have 2. And, that's only for rollback in case of a failure at update time. We don't ever want our users to say, oh, let me go back to that version I was at 6 months ago. If they need that, go to the cloud, issue an update to that specific version. but don't rely on OSTree to do that. You could possibly get away with that, but it becomes, as your question would indicate, it becomes a question of, okay, how big is my repository actually getting if I'm keeping all these information?
So it automatically keeps track of what assets you need for these two versions, and it can just purge everything else.
Yeah, exactly.
Yeah.
Exactly.
Okay.
So
Very
we
nice.
have we have a system called Green Boot. I think came from Amazon, which is basically our way of doing post-install sanity checks. It's a systemd run level with systemd services, and if any of those services in that run level fail, that will trigger our rollback. And so once we exit that and the boot is marked good, then we purge out any old versions that we no longer need.
Yeah.
So I know that, as an engineer at heart, you're always looking at something that you're doing today. There's things are broken, you're fixing them, helping your customers. But then you're also looking at some that's happening around you, which is more futuristic and may not be like rightly put into your devices right now. Or so how do you see the future of embedded systems, or any new technologies you are tinkering with? Or
yeah, well, I'll come back to that whole idea of immutable distros. I actually gave a talk at Embedded World on immutable distros, and it was kind of a combination of embedded and desktop distros. So there's things like Fedora Silverblue, which are based on OSTree.
Yeah.
And I've started playing with that, and I know Ubuntu's got one, which I think is a dual AB type system. So I think that's pretty exciting. Outside of the context of embedded, I think one of the things I'm hoping to do with this Fedora Bluefin-based system is it basically uses an OCI container as the image to install. And so what I would like to do at some point is generate a custom version for my specific embedded development needs. Get rid of all the Kubernetes stuff because I don't do cloud development, add in all the embedded development stuff. And then when my system is old and it's time to replace it, I install fresh and it's got everything I want on there already in that atomically updatable format. So I think that's that. And from our customers' perspective on the embedded side, of course, it's nice to know that the actual bag of bits that I'm running on my entire fleet of devices is identical, right? If you use something like APT to do the updates, you have no idea what combination of packages are on any given device. So any of these immutable type systems where you're guaranteed that you know exactly what version is running, that's a big step for these large fleets of devices. Of course, new technologies, we do a lot of computer vision stuff, machine learning, vision at the edge and all those kind of things. We've got a lot of partners that are camera manufacturers. So that's very big in our field. And of course, the SoCs that we're based on, they have the neural processing units and the high-end GPUs, and our newer chips based on the IMX95. And we've got one, AM69, I think it is. It's a TI SoC that's like 8 core, and it's just an absolute beast. So calling that embedded is almost I have a hard time at some point calling some of these things embedded, but I guess technically they are, because it's more about the workflows and what you do with them.
Yeah, I think I kind of agree with you on this, because so Nixos, for example, is like composable system, right? So it basically goes, so you have a more or less defined system, and anytime you will always get exactly same system once you execute, the next. So do you see that fundamental technology is lacking in this area that, say, some projects like Yocto project or others could use to kind of, buff this into future?
Possibly. I mean, Yocto ultimately does something similar, though, right? And the idea with any kind of open embedded based thing is that it's system as code, which is at the end of the day ultimately what things like NixOS are trying to do. So I guess the big difference is that those systems are more at the binary level rather than at the source level. So is there room to, kind of like we do with Torizon Core Builder, right? Give you the ability to take a pre-built binary and do some changes to it, perhaps. That might be something that the Yocto project wants to do in the future. That could help short circuit some of these long build cycles, right? You have one person making the base build, and then Cliff grabs my image and he makes some changes to it with some standard Yocto tooling without having to do the whole build. Whether that's any faster than just using shared state, I guess, just depends on how it ends up getting implemented.
Yeah. Good. So I think any advice you would have for listeners who are either stepping into the embedded system development or are curious to know and that they should look for becoming effective?
Yeah, I mean, it's a huge field, right? But it's also so easy to get into these days, right? When I was getting started as an embedded developer, an embedded board and tool chain was $4,000 or $5,000 in $1995. So these days you can go on Amazon or Seed Studio or whatever. I've probably got 30 boards that I've never even powered on because I needed, spend $5 more to get free shipping or something. So if you're interested in getting into embedded, just do it. Pick a project. That's another thing, right? Have a problem you want to solve. It's great to go through tutorials and run things, but if you're not actively doing something that's of interest to you, a real problem that has some meaning to you, you're not really gonna learn it, and so you'll follow the instructions, but it won't necessarily stick in your brain. But yeah, just take a look. There's so many options for boards and hardware and all the open source tooling that's out there. If listeners are interested in that, it's very easy to get started these days.
Yeah, that's great advice. And again, back when I was in college, I paid $79 for Borland C++,
Yep,
today
absolutely.
The tools are just there, and it's just amazing opportunities. So,
yeah. So I think having a problem, that is the key, right? So it's essentially going after solving something tangible, keeps you motivated and makes you learn those bits a little bit more intentionally. That's a really good advice. Thank you.
Yeah, but also related to that, let me make one more comment. There's so many projects out there already. Don't necessarily just immediately jump in and say, I'm going to start from scratch on this. See what's out there. See what projects and communities already exist that you can get involved with. Because if you're involved with an active community, you can learn so much so quickly. And you might find a project that's 90% there, and maybe somebody else is having a similar problem, and you can help other people solve similar kinds of problems.
Yeah, a lot of what we do is just assemble things together. So
I very rarely actually write code these days. I mean, I do Bash shell and Python, and that's about it.
Yeah,
it's just gonna get better. Wait a few more years, you'll just speak to it, and that's it.
Yeah.
Anyway, thank you. Thanks a lot, Drew. I think it was quite a bit of interesting information, and it was nice talking to you.
You guys as well.
Yeah, we appreciate your time, and if our listeners have any feedback, please let us know, or ideas for future topics. Until next time, thank you.